Hi everyone, thank you to come to my presentation of Dr. Geo. First at all, I would like to thank the organizer of the event, the FAST Foundation, to invite me to come to present Dr. Geo in live. Unfortunately, I can't come. I would like also to thank Juan Vultic for his work on quiz Smalltalk. So my presentation will be about interactive geometry with programming experience. What this means. First, I will tell you a bit about the DataGeo history. I started to develop DataGeo while I was a student. I wrote it in C++ and it was a DOS application. Can you imagine that? A DOS application. Later, I ported to Linux because it was more aligned with my philosophy. When I met the Squeak Smalltalk, I decided to port it to this platform, to this environment. Later, I port to Faro because there was more feature like the Cairo backend I was interested on. A few years later, I found that Faro was becoming a bit more complicated for me to follow on because there was a lot of new frameworks added to the system. So when you are a hobby developer like me, it can be complicated. So I start to look at quiz for a few years. Then during the COVID event, I decided to jump in and start porting Dr. Joe to quiz. Right now, I'm mostly done with the port, so I think in the coming months you will have final release. Still, there is alpha release you can already download from the Dr. Joe website. So during the presentation, I will first show in the first part, I will present what is interactive geometry. This will be done with the quiz implementation of DataGeo. So you will see new features that are not present in previous version of DataGeo. Then in the part 2, I will present my idea of interactive geometry and programming, what this means for me. So you have to understand that this perspective is done with kids on the keyboard. So let's start with the presentation. The concept of interactive geometry is to draw sketch you can manipulate. Let's take an example. We draw a circle. Then on this circle, we put a line, no, a point, sorry. So when we move this point belongs to this line, of course. If we move the circle, then the point move with. From this point, we can draw a few more objects like a triangle. Whenever we move this circle, the triangle is computed. We can decide to draw, let's say, a perpendicular line going through point on segment. So we know that these three lines, they always go through the same point, this point here. We can ask for this point, of course. Then we can do a bit more. We can do the bisectrous perpendicular. And these three ones, they go through the same point. Okay, it starts to be a bit messy, so we can hide the line we don't need anymore. So this is really about hiding them. We can't delete them because otherwise we will lose the relative constructions. Then we can name this point. Okay, this one will be H. Make it larger. Then this one will be M. change the color, blue, make it larger. So we can draw some other line, like this one is the bisectrix, okay, of the angle. I will not draw the third one because we know that she will go through this point. So we can just ask for this point. Then we paint it with a different color, let's say green, large size. Then we can hide the line there. Yeah. Okay. If we move here, okay. So I forgot to name this one, so maybe it will be O. We can draw the gravity center. So we just need segment to do that. So this point here is the gravity center. Oh, mistake of myself. This point, we can name it J. Different color. Orange, large. Then we can hide the segment. Okay, hide him. Okay. So we have this situation. So when we move this mobile point on the circle, we see that all these 4 points are moving around. So we can do a bit more. We can ask the locus of this point to Dr. Geo. Okay, locus of when this one is mobile. So M is going on a line, a straight line. J on a circle, or on a different curve on H the same. Well, we can paint them to make it a little nicer. So this one in red, a bit larger, and this one also the same, will be green. This one will be orange. Then the same for this one, it will be blue. Then now we can zoom a bit more to see how it is. Close this one. So we have this all curved, so we can see that when we move this mobile point, indeed, these points are moving on their own specific curve. If we decide to move another point of the triangle, for example this point, of course the curve will be recomputed according to the position of the triangle. So that's the funny part. When it's come to Smalltalk, we can play a bit more with specific aspect. So let's try to get the... Okay, come on, boy. Don't be shy. Okay, let's do it differently. Maybe like that. Okay, I can get... Can I get... No, it doesn't want. I don't know why. Okay, I got the locus. Okay, I got you, boy. So this is the locus, and this is a morph. So that's the fun part with the quiz. We can ask to inspect this morph. So we can learn about how it is written. So what we can see, okay, move it there. What we can see, for example, there is samples. How many samples are used to compute it? So we can evaluate, okay, 2000, not so much, 200, sorry. And if I move with a different shape, maybe like that, okay, it should be larger. So we have almost 7,000. We can play also with the parameters that are used to build this curve. So for example, if we set a higher value there, what is going on? Okay, we see that we don't have enough sample. This look like, okay, 11 sample is not enough, of course. We improve these things here. Okay, we have a bit more, but it's not enough. No, I did not save. Okay, we have a few more, but it's not enough. Okay, so what is interesting with the Smalltalk system, as you know, is that you can kind of debug or improve the way you are designing a specific stuff dynamically. Of course, you know about that. Okay, so I think that will be all for the presentation of the specific facet of interactive geometry applied to Smalltalk. The idea of Smalltalk Sketch is to describe an interactive sketch with programming instructions, not with mouse, menu, and click. So this means that you can use the feature of programming language to describe your sketch. We can see from here we have a very short one-line code. This code just asks for a new sketch. When we execute it, we just get the empty sketch. From there, we can ask to this new sketch, okay, to give me, for example, a circle from center 0, 0 with a radius of 5. We can, okay, set a point on this circle. Point at the position 5, 0. Of course, the resulting sketch is interactive, so this means we can drag the object. For example, drag the circle. Oh, the point is not on the line. What's going on? Oh, indeed, we just ask for a point. We don't say we want a point on this line. So if we want to do that, we need to ask .geo to create a point on the sketch on this line. So maybe this time we need to have a name for this object. So this is time to introduce variable. So a variable for the sketch, then a variable for the circle we want to point on. Then, okay, here, circle. And we ask the sketch. So from here, we will have a different instruction. We ask for the sketch, give me a point on the circle. Maybe at the position 0. Let's see. Okay, we have the same sketch, but this time the point is on the line, so we can move the point on the line, and when we move the line, the point is moving with. So from here, there is nothing new if you compare to menu, mouse, and click. If we try to introduce, for example, specific feature of programming language like a loop, this is a bit a different story. So let's say we want to create a few points on this circle. Well, we will use the curvilinear abscissa of a point on a line which go through 0 to 1. So 0 to 1 by a step of 0.1 because we want just 10 points. Then do this. Okay, what we want to do. Sketch. We need a local variable to the loop, which is the curvilinear abscissa. Sketch. Give me a point on the circle, but this time at the position A, which will change over time. Okay, so here we have 10. If we want a bit more, maybe 100, we just change the step. Okay. What about drawing the radius of this of the circle going from the center to each of these points? We can do this in the loop. Let's introduce a local variable to the block. So we have the point P. We want to remember Then, okay, we ask sketch, can you give me a segment this time from P to the center of the circle? Let's see. Okay, we have it. So now we start to see some features that are easier to do with programming language than if you are using mouse and click. We can watch for a few more complete examples of what you can do. Let's say, for example, the Fibonacci spiral. Okay, this is the Fibonacci spiral. Okay, so we have the code here. Then we can edit it. Okay, so we just copy the code on the Smalltalk sketch editor. So we can execute it again. Okay, this is the Fibonacci. And of course, this is an interactive recursive sketch, so we can drag around and see what is going on. What we can do, we can play with the recursive aspect, because we are using block and recursivity to describe this curve. So a smaller one. What's happening only with one iteration? Okay. So of course we can do something a bit different. We can do step-by-step execution. Let's say with that. Okay. Here we go. Just see how it's going on. So from now, maybe, okay, shape, this is the first shape. Step, second one, we can see what is doing in each of the block. Then we can step into if we want. Okay, I think I'm done with the presentation. So here I just show a few examples of the Smalltalk sketch editor, which has been recently developed on Quiz with Dr. Geo. More feature will come, of course. Thank you for your time, and then I'm open to question and maybe a few more demonstration if it's possible. Thank you again.